table below shows the marks achieved by 4 pupils in the spelling test. Here we have our 4 pupils, Seamus, Kelly, Richard and Mairead, and here we have their score out of 20. What is the mean average mark of the 4 pupils? Write your answer in the space below. Well, in working out the mean, we have to do a bit of adding, and then we have to divide by how many people there are. So we've got to add our 4 numbers to begin with. 16, 14, 19 and 15. 6 and 4 give me 10, 9 brings me up to 19 and 5 is 24. 4, 2 over. 4 ones are 4 and then the 2 is 6. And our final step is to take the 64 and divide by how many people there were, which is 4. 4 into 6 goes once, 2 left over. 4 into 24 is 6. So our mean, which is our average, and our answer is 16. Phil played a computer game. The computer game recorded his score each time he played it. He played the game 8 times. His mean, his average score was 14. The range of his scores was 12. The highest score was 21. What was Phil's total score for the 8 games he played? Write your answer in the space below. Oh, so remember, he played the game 8 times and he got a mean, an average score of 14. So that is the same as getting 14 every time he played, all 8 times. So all we've got to do is take our 14 and multiply it by 8. Or you could add all those 14s. 8 fours are 32, 2 down, 3 over. 8 ones are 8, plus the 3 is 11. So his total score was 112. Next question, what was Phil's lowest score? Write your answer in the space below. Well, we know that his highest score was 21, and we know that the range was 12. Remember, the range is simply the biggest score, take away the smallest score. Well, if we know the range is 12, we know his biggest score was 21, we have to work out his smallest score. So we simply do a bit of subtraction, and we take the 12 away from the 21. 21 take away 12. So we then can work out that his smallest score is simply 9. Maeve keeps a record of the amount of water that she drinks from her water bottle in class each day. She draws the graph below to show how many millilitres of water she drinks during the school week. So on Monday we can see she drinks 800, Tuesday she drinks 400, and so on. First question, question A. Over 2 consecutive days there is a 25% increase in the amount of water that Maeve drinks. Write the 2 days in the space below. Well, at a quick glance we can see from Monday to Tuesday there's a drop in the amount of water that she drank. So we can rule out Monday and Tuesday. And we can see from Thursday to Friday there's a huge leap in the amount of water that Maeve drinks. So that's going to be a lot more than 25%, so we can rule those out. So we're going to focus on the middle 3 days, and we're looking for an increase of 25%. If I look at Tuesday, I can see that's 400. And on Wednesday, she drank 500. That is an increase of 25%, because if I have my 400 and I find out 25% of it, which is just 1/4 of 400, that is 100. And if I add that to 400, then it brings me up to 500. So those are our 2 days, the Tuesday and the Wednesday. Question B. Maeve had more water to drink on Monday than Thursday. How much more? Well, this question is just checking, can you read the scale? So all we've got to do is look at Monday's total, which we can see is 800 millilitres. And then we look at Thursday's total, which was 600. And you just do a subtraction sum. Quite easy, 200 millilitres more. And on what day did Maeve drink the greatest amount of water? Well, that's a straightforward one. Read from the graph. Friday. Primary 7 are returning from their school trip to Edinburgh. They start from their hotel, travel by bus to the ferry terminal. They get back on the ferry and sail across to Belfast. Then they get a bus from Belfast back to their school. Their journey is shown in a graph below. Question 1. How far had they travelled from their hotel at 1300 hours? Write your answer in the space below. Well, this question is just checking, can you convert 1300 hours into a 12-hour clock? And that is 1 p.m. So if we look at 1 p.m. and we're looking to see how far they've travelled from their hotel, and we can see that it's 40 miles. Question 2. How long did the Primary 7 stop for lunch? Write your answer in minutes in the space below. Well, at any point in the graph where it is flat, it means they are not moving. So we are looking to see how long this lunch period was. So we've got this gap here. So it runs from 12 p.m. to 1:30, which is 1.5 hours, which is 90 minutes. Question 3. Sailing on the ferry was the longest part of the journey. How many miles did the ferry travel? Well, we can see that there's a middle section where our graph is going up. This is our longest part of the journey. So that's whenever they're on the ferry. And we're looking to see how many miles they travelled. So if we go across from the bottom of that incline, it's at 40. And the top of the incline, it is at 170. It's between those two markers. So we're counting from 40 up to 170. So they were on the ferry for 130 miles. A shopkeeper creates a table of his best-selling products one Saturday. The products are shown below. Crisps, chocolate bars, mints, chewing gum, and a bag of sweets. The shopkeeper then uses the table to draw a pie chart below. Write the name of each product in the correct box. One is done for you. So they've already done mints, so we don't have to worry about those. Well, I can see that my biggest number is 60, so it's going to go into my biggest section. So I'll put in a bag of sweets. And my next biggest section is my crisps. So it falls into this section here. That's another one used. We're left with 2 remaining ones and they're both the same size. So I could have my chocolate bars over here and I could have my chewing gum on this side. The pie chart below shows the types of homes lived in by 60 children. The number of children who live in a terrace house is 5. How many children live in detached houses? Write your answer in the space below. Okay, well we know that terraced houses are 5. We have 60 children. I can see that semi-detached is a right angle, as is apartment, making those both a quarter. So a quarter of 60 is 15. So I know that the apartment is 15 and detached houses are 15, semi-detached. We then have to figure out what the question wants to know. How many people live in a detached house? So it's simply 60, the total number of children. Take away 15 plus 15 plus 5. So 60 take away 35 equals 25. 25 live in a detached house, which is our answer. Okay, in this question, we're focusing on Venn diagrams. A school offers after-school activities including football, chess and art. Venn diagram below shows the number of pupils who attend these clubs. So everybody within the chess circle would attend chess, everybody within art goes to art, and football goes to football. This section here, where chess and football overlap, those two only go to football and chess. In the section in the middle, where there's 3 people, means that they go to all 3 clubs. Well, let's look at the first question. How many pupils attend football and art, but not chess? So we're only interested in the people who go to football and art, but not chess, so we don't want anybody in the chess sections. So we can see there in the centre, football and art. The answer is 6. Let's remove those so it doesn't confuse us with the next question. Question B. How many pupils attend chess and art but not football? So we're looking for chess and art but nobody who's in this football section. So chess and art, you can see that it's 5 pupils. Again, let's get rid of this. And our last question, how many pupils attend chess club? Well, we would just have to count everybody who is within the chess circle. So we would have 8, 2, 3 and 5, and you have to add them all together. 8 and 2 give me 10, and the rest bring me up to 18 people. That would be our answer for the last question. Look at the 8 numbers in the box below. Now look at the decision tree. So, we have to write each of the numbers in the correct box of the decision tree. 2 of the numbers have already been put in the correct boxes. So they have already used 11 and 12. Write each of the remaining numbers in the correct box. You may have more than one number in a box. The best way to approach this question is to take one number at a time. So we'll begin with the number 2. And we'll start from the top of our decision tree. Is it a prime number? Yes. Is the number odd? No. So 2 belongs in this box. Let's take the next number, number 9. Again, begin at the top of your decision tree. Is the number prime? No, because we've been divided by 3. Is the number even? No, so 9 belongs in this box. On to our next number. Let's try the number 23. Begin at the top. Is it a prime number? Yes. Is it a prime number? Yes. Is the number odd? Yes. So 23 belongs over next to 11. Next one, 29. Is it a prime number? Yes. Is it odd? Yes. So 29 also belongs in that box. Next one, 15. Is it a prime number? No. Is it an even number? No. So 15 belongs in the same box as 9. And our last one, 18. Is it a prime number? No. Is the number even? Yes. So it belongs in the same box as 12. A bag contains 40 sweets. There are 10 yellow sweets, 20 orange sweets and 10 red sweets. It is not possible to see into the bag. Look at the probability line below. The letters A, B, C, D and E show they are equally spaced positions on a probability line. A is impossible, ranging up to E, which is certain. A pupil puts her hand in the bag and chooses a sweet. Each statement can be completed by choosing a letter. Complete each statement using a letter from the probability line. Okay, the first statement. Arrow something shows the probability that a green sweet is chosen. Okay, well, there are no green sweets. There's yellow, orange and red. So that has a 0 chance in 40 of happening, meaning it is impossible. So that must be arrow A. Next statement. Arrow something shows a probability that an orange sweet is chosen. Well, there are 20 orange sweets. And there are 40 altogether. So 20 is half of 40, meaning that is an even chance. 50-50 chance. So it is C. So we've used A and we've used C. Next statement. Arrow something shows the probability a yellow sweet is chosen. There are 10 yellow sweets. So 10 over 40, which is the same as 1/4. So a little bit less than half, so we've only got the option of B. So arrow B completes that statement. And then our next statement, arrow something shows the probability a yellow sweet isn't chosen. Well, a yellow sweet to be chosen, there's 10 of them, So a yellow sweet not to be chosen would be 30 over 40, which is 3/4. So that is our D statement. It's not certain because that would be 40 out of 40, but it's close to the E, so it must be D. Boxes X, Y, and Z contain coloured cubes. The number of cubes in each box is, and here's what's in X, here's what's in Y, and here is what is in Z. Sean closes his eyes and takes a cube from each box. From which box is he most likely to choose a black cube? Well, let's go through it. Box A, I have to add it together, has 12 cubes. And of the 12, 3 of them are black. Box Y has 8 cubes and 4 of them are black. And box Z, quick bit of addition, has 15 cubes and 5 of them are black. Well, at a quick glance you can see that he is most likely to choose a black one from box Y. He has a 50-50 chance because half of them are black. So our answer is box Y. 4 bags contain coloured cubes. The bags are labelled 1, 2, 3 and 4. The contents of each bag is shown below. So here's what is in bag 1, bag 2, bag 3 and bag 4. Johnny takes 1 cube from each bag without looking into the bag. From which bag is he most likely to take a red cube? Okay, so a little bit like our previous question. Bag 1, he has 15 cubes. 3 of them are red. Bag 2, he has 12. And of the 12, there are 4 red. Box 3, there are 4 and 2 are red. On box 4, there are 7 and 4 are red. And we're asked to work out which one is he most likely to choose a red cube from. Well, we can see that over half of them are red in bag 4, which is the greatest amount compared to the other remaining bags. In bag 3, he has a 50-50 chance, 50% of them are red, but more than 50% are red in bag 4, so he's most likely to choose a red if he goes into bag 4. Look at the 6 number cards below. These cards are shuffled and placed face down onto a table so that the numbers in each card cannot be seen. So we've got 7, 3, 2, 4, 9 and 6. One card is picked at random and turned over. Look at the following 5 statements. A. There is a square number on the card. Well, there are 6 cards. And a square number is a number that's been multiplied by itself. So 4 is a squared number because it's 2 times 2. 9 is a square number because it's 3 times 3. And that's it. So we have 2 squared numbers out of the 6. Statement B. There is a number less than 10 on the card. Again, there's 6 numbers. And we can see that less than 10 is all of them. 6 of them. Statement C. There are 6 cards. How many are factors of 12? Well, which numbers divide into 12? 1, 2, 3, 4 of them. Next statement. There is a multiple of 3, so it's in the 3 times tables. Again, there's 6 cards. Let's see how many of them are in the 3 times tables. 1, 2, 3. 3 of them. And of the 6 cards, how many are cube numbers? So that's a number that's been multiplied by itself 3 times. So 2 cubed would be 2 times 2 times 2. 2 times 2 is 4, times 2 again is 8. And if I have a quick look through, none of them are cube numbers. So E is impossible. There's 0 chances out of 6. B is certain. There's 6 chances out of 6. D is an even chance because it's 50-50. 3 is half of 6. So that's D. My next one, A, would be unlikely because there's only 2 of them. And my likely statement would be C because there's 4 out of 6. Look at the cuboid below. Its dimensions are 8 centimeters by 7 centimeters by 3. So we see that's 8 centimeters long, 3 centimeters wide, 7 centimeters in height. What is the total length of all the edges of the cuboid? Write your answers in the space below. Well, a cuboid has 12 edges. So we will need to add 12 numbers. There are going to be 4 eighths. 1, 2, 3, and 4. There will be 4 sevens. 1, 2, 3, and 4. And the same with the number 3. There's going to be 4 of those. 1, 2, 3, 4. So we do 4 eighths are 32. 4 sevens are 28. And 4 threes are 12. If we add them all together then, 8 and 2 is 10, plus the other 2 is 12. Then we've got 3 and 2 are 5, plus the 2 is 7. So the total length of all the edges would be 72 centimeters. Question 2. The cuboid has 6 faces. What is the area of the face with the largest area? Write your answer in the space below. Okay, so let's work out the area of a few different faces. The area of the face on this side, 3 times 7, would be 21 centimeters squared. The area of the face here would be the 8 times 7. And 8 times 7 then is 56. So this face, the area would be 56 centimeters squared. And the face on top would be the 8 times 3 would be 24 centimeters squared. So we can tell that the biggest area and the largest of the faces would be 56 centimeters squared. The cuboid below is 7 centimeters by 6.4 centimeters by 2 centimeters. So length is 7, width is 6.4, and height is 2 centimeters. What is the volume of the cube? Well, volume, we're going to take the length, going to multiply by how wide it is, and then we're going to multiply by the height. So if we put those 3 numbers into our sum, we take our 6.4 and we're going to multiply it by 2, giving me 8 and 12, so 12.8, and then we're going to multiply that by 7. 7 times 8 first, 56, so 6 down, decimal points in a line of 5 over. 7 times 2 is 14, plus your 5 is 19, 1 over. 7 ones are 7, plus your 1 gives me 8. 89.6. Look at the cuboid below. ABCD is a square. Each side of the square is 4 centimeters. The volume of the cuboid is 80 centimeters cubed. What is the length of AE? Okay, so we know that A, B, C, D, and E is a square with each side being 4 centimeters. So the area of this square is 16 centimeters squared. So we know that the volume is our length multiplied by our width multiplied by our height. Well, we've already got 2 of those, and we've worked out that there were 16. So we need to work out that width, which is AE. We know that the volume is 80. So we need to divide 16 into 80 to work out what that AE is. And 16 into 80 goes 5 times. So my line AE is 5 centimeters. I face east. I turn 135 degrees anti-clockwise. In what direction do I now face? First thing we need to do is to draw ourselves a little compass. North, south, east, and west. So if we're facing east and we turn 135 degrees anti-clockwise, so if I turn 90 degrees, it would take me to north, and then I would turn the further 45 degrees, because the 90 plus a 45-degree turn brings me to 135 degrees. There's my 135-degree turn, anti-clockwise, remember. And we're now facing north-west. A ballerina spins on the stage. She turns 2¼ times before stopping. How many degrees has she turned? Well, one complete spin is 360 degrees, and she does that twice. She then spins a quarter of a full circle, so 1/4 of 360 degrees. So let's work out what 1/4 of 360 is. 4 into 360. 4 into 36 goes 9 times, 4 into 0 is 0. So she turns a further 90 degrees. So we've got 360 plus 360 for the 2 full spins, plus the 90 for the quarter spin, and we add them together. 9 and 6 are 15, plus the other 6 is 21. 6 plus 2 is 8, so she has turned 810 degrees. Shauna is facing south. She turns 45 degrees. In which direction is she now facing? There are 2 possible correct answers. So first thing to do, draw yourself a little compass. North, south, east and west. We're told that Shauna is facing south, and she turns 45 degrees, which is half of a right angle. So she could go 45 degrees anti-clockwise, which would bring her to southeast, or she could go 45 degrees clockwise, which would bring her to southwest. So those are our 2 possible answers, south, west and southeast. Look at the clock below. The hands on the clock show that the time is 4 o'clock. What is the value of the reflex angle between the hands of the clock? So we're looking for the size of this angle, the reflex angle. So if we divide our clock up into our 90-degree angle, and it's been divided into 3, we can tell that the gap between each of the hours is 30 degrees, because 3 30s give us that 90 degrees. Then we can look at the time. So we've got 1, 2, 3, 4, 5, 6, 7, 8. We've got 8 of the 30 degrees. 8 zeros are 0, 8 threes are 24. So our reflex angle is 240 degrees. Not to be confused with the obtuse angle, which is in between the 12 and the 4. Look at the grid below. Plot the points 3, 2, 7, 2 and 3, 4. Okay, let's begin with those then. So we go along the corridor to 3 and up the stairs to 2. Along to 7 and up to 2. Along to 3 and up to 4. Okay, when a 4th point is added to the grid, the 4 points can be joined to form a rectangle. So we join our previous 3. We can see that there's only one viable option for our 4th to make a rectangle, and that is it's 7, 4. Question 2. Plot the points 2, 8, 2 and then up to 8, 2, 10, 2 and up to 10, 4, 10, 4 and up to 10. And it tells us when a 4th point is added to the grid, they can form a square. Again, there's only one viable option, so I'll connect my original 3. And there's only one option to make a 4th to complete the square, and it's going to be 4. Whoops. 8. 4, 8. And I can join all the lines just to confirm where there is our square and there's our badly drawn rectangle. Look at the triangle and quadrilateral below. By how many degrees is C greater than B? So we need to work out what C is, and we need to work out work out the size of angle B. So within a quadrilateral, all the angles add up to 360. And we already know 3 of them. So we're going to have to subtract 90 plus 90, the 2 right angles, plus 75. So we've got 180 plus 75. Our sum is then 360, and we're subtracting 255. 0 take away 5, can't do, so a little bit of exchange. 10 take away 5 is 5. 5 take away 5 is 0. 3 take away 2 is 1. So my angle C is 105 degrees. Within a triangle, the angles add up to 180. And we already know 2 of them, so we need to take away 47 plus 72. So let's do that sum first. 47 plus 72. 7 and 2 are 9, 4 and 7 are 11. So we have to take 180 and we have to subtract 119. A little bit of exchange again. 10 take away 9 is 1, 7 take away 1 is 6, and 1 take away 1 is 0. Angle B is 61 degrees. Now we can work out the difference between the two. We take our 105 angle, which was C, and we take our 61 angle, which was B, and we do a subtraction sum. 5 take away 1 is 4. 0 take away 6 you cannot do. Some exchange again. 10 take away 6 is 4. My missing angle for my answer then, the difference between them is 44 degrees. Look at the hexagon below. There are 6 equal angles drawn in the centre of the hexagon. Each angle is size A degrees. What's the value of A? Well, this question is just checking, do you realise that a full circle is 360 degrees? And it has been divided up into 6 equal angles. So you just divide 6 into 360. Gives me 60 degrees, and that is the size of each angle A. Look at the 2 triangles below. The triangle HIJ is an isosceles. The sides HI and HJ are the same in length. Triangle KLM is an equilateral. By how many degrees is angle A greater than angle B? Write your answer in the space below. Okay, we know that the triangle on the right is an equilateral, so each angle must be the same size, so they're all 60 degrees. Because remember, the angles in a triangle add up to 180. For triangle on our left, it's an isosceles, meaning this angle down here, A, is the same as this angle over here next to the letter J. So again, they all add up to 180. Let's take away the 28 that we have. Some exchange. 10 take away 8 is 2, 7 take away 2 is 5, 152. But that 152 must be split between these 2 bottom angles. So I need to divide it by 2. 2 into 15 goes 7 times, it's 1 over. 2 into 12 goes 6 times. So each angle at the bottom here is 76 degrees. Now we can work out how many degrees bigger A is than B. Because A is 76, B is 60, we can do a little bit of mental math to work out that the difference is 16 degrees.